Okay, welcome to Saxon Math, Lesson 47, Powers of 10. So we are going to put the mental math off to the end if we have time, because we've got the librarian coming, and we want to make sure we have time to actually go through the examples here. So otherwise, I'm sure anyone listening to this at home can work on the mental math on their own. Anyway, so yeah, powers of 10, and I think this is, we've literally been doing these in the mental math, so I don't think that anything here will come as a shock to anyone. So it's just a matter of, I guess we're just reviewing what are the rules for multiplying. You've got like numbers and exponents, and you're multiplying these. What kind of exponent will you end up with at the end of that? And so there's just, well, basically a simple rule for each of these. Very simple rule. So how about on the first one? So we've got 2 to the power 4 times 2 to the power of 2, or 2 squared. So what would be the rule of what do we do with these two exponents in an operation like this?
Yeah. Add them?
You add them! Excellent! So let's everybody do that. What?
I feel like these Saxon math guys are trying to insult us.
Okay, this is a little insulting, but we'll get through it fast.
Wait, can we write the rules of exponents? Because I think
it just says find the missing exponent.
no, like on the paper, because there's like a rules and exponents thing. Can I write that down?
If you like, you could write it down, but I mean we've been going over this multiple times. All right, and then division being the inverse operation of multiplication. So if we're dividing these, what would be the rule for that? Oh, don't raise your hand again. Yeah.
Subtraction?
Yeah, you subtract them. So in this case, it's 4 minus 2. Getting us 2 squared. Da-da. No. So, I mean, that's why it's good for us to be reviewing this. Yeah, because we're talking about the exponents. And so the rule is if you are multiplying like numbers that have exponents, then you can just add the exponents together. And if you're dividing them, then you subtract the exponents. So we ended up with 2 to the power of 6 here, and then just 2 squared here. And then you could think of C in a couple of different ways. One, you could think of it in terms that that multiplication is just repeated addition. So you could just look at this as 2 to the power of 4 times 2 to the power of 4. And so following that rule, we would just do what with these numbers? Add them. And so we get 2 to the power of 8. But and you know, if that's what you need in order for this to be simple and intuitive, that's fine. But in a situation like this, what could you really do with those two numbers, sir?
Multiply the two exponents?
You can multiply the two exponents for these. So you can do just 2 times 4 and get the same answer.
Yeah.
But you know, if trying to remember 3 different rules for this feels a little tricky, then you can just write it out and think of it in terms of expand it out and just follow rule number 1.
Mr. Petrie?
Yo.
So for for C, if you had instead of the exponent of 2 after 2 to the power of 4, what if there was like another number instead of that 2? Would the same multiplying rule work?
What you mean if you had something like 2 to the power of 4 times 3 to the power 3 squared?
Yeah. No, like if you do 2 to the power of 4, and instead of that 2 like next to it.
Oh, you mean if this was a 3?
Yeah. So
well, we can do that as repeated addition and see. No.
Okay, so
And yeah, it works, right? Okay, good question. Yes, yeah, it should work in any situation, I would think.
Wait, Mr. Petrie?
Ooh.
I
think you may or may not have brought it multiplication sign next to the 2 to the power of 4 plus 2 to the power of 4.
What, you mean that I made this too tilty or something?
No, the multiplication sign next to the 2 to the power of 4.
Oh, yeah, sorry, yeah, okay. Here. I made them too tilty, but not in that way.
No, in the other one. 2 to the power of 4 plus 2 to the power of 4.
Oh, did...
The first one.
No, like that one. The one that equals to 2 to the power of 8. Yeah.
Wait, no.
No, that is a multiplication sign.
I was talking about this one.
Yes, okay, I fixed it. Alright, expanded notation using powers of 10, and this is a nice little introduction to if we were talking about the scientific notation, which we'll cover this later on. But so expanded notation. So if we're thinking sort of standard Saxon expanded notation. Remember, we would kind of do this out as 5 times 1,000. Oops, moment. Plus 2 times 100, right? Plus, well, just 6. Now, so that's just expanded notation, right? Well, so how do you think that we would write this if we were using powers of if we were using exponents instead of zeros here? What do you think? Okay. Yes. How could we rewrite this in a more elegant way? I mean, imagine if this was like 520,000 sort of thing. Like that ended up being a lot of zeros, right?
So you're asking to convert the 1,000 to 10 to the power of something?
Yeah.
Okay, so you would do 10 to the power of 3.
Mhm.
For 5 times 10 to the power of 3.
Mhm.
Then 2 times 10 to the power of 2. And then for 6, you could do.
Oh, here's the tricky one, and here's the point where we can remember a special rule for a weird trick for exponents. Yeah.
You can do 6 times 10 to the power of 0.
Excellent. Ooh. Yes.
Give
Give that man a pom-pom.
Yes, sir.
For remembering so remember anything. One weird rule to remember here is anything that has an exponent of 0, that just makes it 1. So that's just a very strange way of writing 6 times 1, and it doesn't matter whether it's a 10 or whether it's 4 or anything else. Just anything with an exponent of 0 equals 1. That's it.
It should be 0.
Right. No, there's apparently a thing if you got like 0 to the power of 0, then it like breaks a hole in the universe. So okay.
Oh, this is.
And then this is insulting.
Wait, this is.
Yeah, okay. Hey, tell you what, everyone do this really quickly. I'll take one deep breath. I bet every single person here can do this. So I'm gonna just do this and double check yourself with me in a minute. I know. Well, it's good. We'll probably have time for the mental math then, right? Okay, all right. Well, let's just get through it quickly then. They're mean. Okay. It's just a nice review. We'll think of it like that. So, yes, this is really 46 and 235 thousandths times 100, which essentially just means we're moving our decimal place over by 2. So just 2, boingy, and it would go there. Last time I checked. So then we would end up with an answer of 4,623 and 5/10.
This question is baloney.
Oh, okay, well, here, it's over, it's gone. All right, hey, let's have a little fun with this. Okay, I bet you can do this too. I'll give you a moment. Right, 2.5 billion. No, but this is a good thing to remember. This term, standard form, like, cause, like, wait, what's standard? We got all these different forms. What's standard form? Well, standard form's just write the number. If you see standard form, that just means the number, the way you've always written numbers. No weirdness, just write the number.
Writing scientific notation
For the
so
example
easier.
before, I took the time to torture myself.
Oh.
How many zeros are there? 1, 2.
Okay, so I'm assuming you probably have it written down by now. At least I'm getting it started. Okay, so here's my place value. So got my ones, my tens,
I want to do an expanded notation.
my hundreds, my my thousands, huh?
Couldn't I just skip from first grade to fifth?
10,000s, 100,000s. Uh-oh, I actually probably need to start writing this smaller. Then my millions. Do ovals. My 10 millions, then. So, what's another way of saying 500 million? Using the word millions instead, yes.
500 million.
Very nice, yes. And then my billions place. There we go. Ta-da!
Wow, writing it in scientific notation is so much easier.
I know, right? So when we get to scientific notation, yeah.
I wrote it in both ways.
Right. So that would scientific notation would just do 3 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. Power of 8. What that would look like.
Oh, I did 2 times 10 to the power 9 plus 5 to 5 times 10 to the
Yeah. All right, people.
What is this?
More bungies. All right, I will give you a moment to do this faster than me.
How many examples are there?
5.
Wait, we're finally done with this.
Yeah. So I think we'll have time for mental math.
Yes.
I guess we should have led with that. Alrighty, so giving you a moment to demonstrate your prowess and be able to solve this. Before I do my little demonstration. So, yes, this just means divided by 10,000, which really just means moving your decimal place over by 4 places. So you take your decimal and just go 1, 2, 3, 4. 0.
Our ego is diminished.
Oh no! Have a nice big ego that this seems so simple.
Your ego will be fueled from this.
Yeah. Like wow,
It looks so complicated.
math is so easy.
I think it'd be safe to use easy here.
I think it is safe to use easy here. Yes, as we know, I do not like that word, but this is pretty easy. Yeah, pretty. Yo. Oh, okay. Yeah, that's totally fine. Well, basically, if we're multiplying, so say we had 3. See, and this is why I do not like the word easy. Is what's easy for one person is not easy for another, and that's kind of cool. So say if we had it times 10 to the power of 4, then that's really like it's times 10,000, which basically would mean that we are moving our decimal place 4 points to the right. 1, 2, 3, 4.
That would be 35.
Right. So we'd have 35,000. So if we are dividing it by 10 to the power of 4, that means we're bringing that decimal 4 places to the left, right? So 1, 2, 3, 4. So we put zeros in those empty spots. We need to put a decimal, and
I got kind of confused where the P is.
probably just because I was doing it like up and whoops. Probably because I was just kind of doing it up there with the writing, right? Anyway, so yeah, so essentially you can just rewrite it as that. So it's just dividing by powers of 10. You bring your decimal to the left, multiplying by powers of 10, you bring it to the right, and the exponent is handy because that's just how many jumps you do. So is that pretty clear? Oh, hey, we never talked about number 15, did we? Remember number 15 from the homework?
Wait, can I?
Well, there's not that much to it. If you put your coordinates in the correct place, then be there.
Number 12. Yeah. It was number 12.
Oh, was it number 12? Okay. You put them there, and so essentially you've got your height, which is there, which is 3, and you've got your what's a nice color here? Let's be a different color. And then you've got the base, which is 4, right? So that's essentially 3 times 4 divided by 2 units, which will get you 6 skunits.
I thought it was 4. I mean, I thought the height was I thought the height was 4 and the base was 5. So I multiplied 4 times 5.
Okay. So you were basically stretching it out to here and stretching this out as many lengths as it went there. Yeah, I think that's kind of how they were trying to get you with this. So it's right. It makes sense, but it's good to talk about. So remember, it doesn't matter what the lengths of the sides are. It matters about the height. And then your base just goes as far as the base is supposed to go.
Base times height divided by 2.
Yes, base times height divided by 2. Okay, well, it looks like we got 5 minutes, so mentally math!
Yes, mental.
Actually now.
Yay! Okay. All right, I will take a couple of deep breaths, let you get out ahead of me.
Mr. Bradley,
Mm-hmm.
on the problem B, it's literally what we're learning.
Oh yeah, no, an E is literally what we're learning. So yeah, it was funny this morning. It's like we covered essentially 2 of the examples from identical things to 2 examples from the lesson in the mental math.
Yeah.
Yeah. Okay, and okay, so that probably gave you a moment. Oh, also we will talk about letter G. Is she coming? Oh no. Never mind.
She's almost. She's not on the ramp yet, though.
Okay, well. Okay, fine. So this is basically the equivalent of 40 plus $1 being $41. This is 3 boingies to the right, boingy, 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 getting us 15. This is essentially kind of a times 1.5 sort of thing, so I could make C equals 6. This one is 5 times 20.
100.
100. This is to the power of 5. This one would be 50.
E32.
Hey, we'll skip G, but really quickly. So there was a good question, and he's not here today. But anyway, what's the most popular one here for the mode?
321.
Mm-hmm. So 321. And someone was asking yesterday about what happens if there are two that have the same number of, like, basically if you have two ties for the mode. And it is true that they are still both the mode, but it's called being bimodal.
What?
And if you've got more than two, it's called being multimodal.
Yeah,
Okay, good talk. I'm gonna stop.